Hey, Algebra 1. Today's lesson is going to be on solving absolute value equations, okay? Before we start doing that, though, we need to define what exactly an absolute value is. And just like you see on the screen here, the absolute value of a number is that number's distance from zero, okay? When we talk about notation here, when we talk about the absolute value, it looks kind of like what we have here. The absolute value of 3 looks like this. It's got vertical bars are on both sides of the number we're taking it. And when we talk about the distance from zero, so we have a number line, okay? And we're talking about 0, and then 3 is obviously greater than 0. So we talk about what this distance is here. So from that number to 0, we know that that's going to be 3, okay? That's a basic definition of absolute value. If we're going to apply it to other numbers, take a look at 4, negative 6.4, and negative 2. Once again, take a look here, draw my number line, put 0 in the middle, okay? Let's say we're talking about 4 here, okay? So 4, once again, if we were to put all the numbers in between there to 0, we know that 4 has a distance from 0 of 4, okay? Same thing goes if we have negative 6.4. So let's see, 1, 2, 3, 4, 5, 6, 7. 6.4 is going to be probably right about there. And if we were to talk about how far this is to 0, we would just say, all right, that's a distance of just 6.4. Okay, same thing goes for negative 2. Okay, if we have negative 2, that's a distance. This is negative 2 here. That distance has got to be positive 2. Okay, so a couple things we need to talk about when it comes to defining absolute value. First of all, it's always going to be a positive number. Okay, when we talk about distance, we always want to measure it as a positive number. The only case in this where it won't be positive is if we're taking the absolute value of 0. Okay, in which case it would be 0. Okay, but in this case, because we're taking the absolute value of both positive and negative numbers, like we see here, they're always going to be positive. Okay, when we solve an absolute value equation, this is kind of an example of what it would look like. So absolute value of x is equal to 4. So we've got to ask ourselves what numbers, hint, hint, more than one number, has a distance from 0 of 4? Well, first obvious answer is that x has to be equal to 4. And then the other answer would be x is also equal to negative 4. Okay? The reason being is that both of these numbers, both of these integers, have a distance from 0 of 4. It doesn't matter if they're both positive or negative. In this case, because both of them have a distance from 4, their absolute value both have to equal 4. Okay, same thing goes for the example right here. Absolute value of x of a number is equal to 6. There are two possibilities. We can get x is equal to positive 6 or x is equal to negative 6. Okay, and we can check that. We know that the absolute value of 6, once again, distance from 0 has to be 6. And then the absolute value of negative 6, oops, let me try that again. Absolute value of negative 6 is also going to be positive 6. Okay, but because this is algebra class, it's going to be a little bit more complicated than just simply solving a one value equation. Sometimes you run into things that look like this. Absolute value of x minus 3 is equal to 4. Okay, so now we're looking at specifically what numbers can I replace x with that would give me a distance from 0 of 4. And the way we deal with this is we say, okay, we've got our absolute value by itself. I'm going to split this into two separate equations where we're going to make this x minus 3 is equal to positive 4, and then x minus 3 is equal to negative 4. We just want to solve both equations the same way because the absolute value has to have a distance from 0 of 4. And that's how we get that positive 4 and negative 4 here. Okay? And we're going to solve both of these. We're going to add 3 to both sides of the equation. X minus 3 plus 3, 3 is combined to give me 0. I'm left with x. 4 plus 3 is 7. I'm giving my answer away already. How about that? All right. And then I do the same thing to the second equation, which is equal to negative 4. Add 3 to the left side, add 3 to the right side of the equation. Negative 3 plus 3 again combines to give me 0. I get x is equal to negative 1 when my negative 4 and positive 3 combine. And I can plug these values for x back into my original absolute value. Here's what I mean. If we take the absolute value of 7 and take away 3 from that, 7 minus 3 is 4. The absolute value of 4 is 4. Same thing if I do negative 1. So negative 1 minus 3 I'm taking the absolute value here. Negative 1 minus 3 is negative 4. The absolute value of that is going to be 4. Okay, so once again, these are just checks to make sure we're solving these correctly. All right. Another example, if I have the absolute value of x plus 2 is equal to 4, where x is just any number, I want to once again separate these into two equations. X plus 2 equals positive 4, and then x plus 2 equals negative 4. Okay, that's what taking the absolute value means. But the nice thing is that this is a one-step equation for both examples. So instead of adding 2, I'm going to subtract 2 from both sides. 2's combined to give me 0. I'm left with x, and 4 minus 2 is 2. Okay, that's pretty easy because you know that absolute value of 2 plus 2, that's going to give me 4 because 2 plus 2 is 4. And then if I do the same thing to the second equation, subtract 2, that gives me x again, but in this case it's going to be negative 6. So when I replace x with negative 6 in the original equation, negative 6 plus 2, well, that's going to simplify to the absolute value of negative 4, which we know the absolute value of negative 4 is 4. Once again, both check out to give me good answers here. Okay, but let's take a look here at another example. Something different about this particular equation. 2 plus the absolute value of 2x minus 3 is equal to 22. Excuse me, is equal to 22. So what we want to do is, before we split it into positive and negative numbers, I have to deal with this positive 2 here. I want to get rid of that so that way I have the absolute value of 2x minus 3 by itself before I split it. So I'm going to start by subtracting 2 from both sides of the equation. When I do that, 2's combined to give me 0 and cancel out. I'm left with the absolute value of 2x minus 3 is equal to 22 minus 2 is 20. Okay, now I'm ready to go ahead and split this into positive and negative 20. So the way I do that is I have 2x minus 3 is equal to positive 20, and then 2x minus 3 is equal to negative 20. And I would solve these the same way, just with different numbers on the right side of the equal sign. First step, go ahead and add 3 to the left and right side of the equal sign. 3's canceled, combine to give me 0. So 2x is equal to 20 plus 3 is 23. And then I reduce everything down by 2, and I'm left with x is equal to 11.5. All right, so that's one solution here, and we can replace that into the original to double check it. And then when I go to solve the second equation, same thing. Add 3 to both sides of the equation. I get 2x is equal to negative 17. Reduce everything down by 2. Odd number divided by 2, that doesn't scare us. That gives me negative 8.5. Okay, once again, decimals are numbers too. They deserve just as much to be in any equation that we would see. Okay, your homework for this weekend is to do the following. You are going to finish your knowledge check on ALEKS, and then there will be an assignment called Inequalities and Absolute Value Review. Okay, that's going to be due next week. You have all weekend to get it done. Make sure you get as much work as you can get done, and I will see you on Monday. Drop a like if you learned something from this video.